Alright, so the next part, we're going to switch over to the other classwork paper. And this should look very familiar. We're going to start off quickly reviewing transformations, and this is specifically going to be talking about quadratics. So we're going to look at number 1 on that paper, and hopefully you quickly realize that this is a reflection about the x-axis, because the negative is on the outside, and then down 2. So go ahead and pause the video, try those next couple, and then hit play when you're finished. Number 2, hopefully you got this. It went right 1 and up 3. Number 3 should be compress horizontally, except you should have had 1/3, not 3. So compress horizontally by a factor of 1/3, and then left 1. And for number 4, reflect about the x-axis, and then translate up 2. Alright, so these ask you to do basically the same things, but backwards. It says expand horizontally by a factor of 2, and when you're working through these, if you get one that says to compress, then make sure you just put a 1 over whatever value they give you, because they're only going to give you whole numbers. Make sure you put a 1 over for if it says compress. Well, this one says expand, so 2 is correct. So expand horizontally means inside of the squared, I'm going to put 1/2 x, but then it wants me to move it right 1 unit, so I'm going to put 1/2 x minus 1 squared. And that's very good. Go ahead and try the next, and pause the video, try the next couple. I'll go over the answers. Number 6. Number 7. And number 8. And number 8 was one I was talking about where it says compress, so that should be a 1/2. And so the reciprocal of 1/2 is 2 that goes inside there. Alright, so now it says to graph. Well, again, we've done these as well. So when I'm graphing, I see that my normal one would start here, here, and then up to 1, 2, 3, and run off my graph. So that's what my normal one would look like. Well, this is asking me to reflect about the x-axis. If I reflect about the x-axis, that just flips all those values into that. So if it just asked me to reflect, I would do that. But then that -2 means I need to shift everything to the right 2 units. So I'll shift each point right 2. And I should make a parabola using those green points. And I would get that. So go ahead again, pause the video, try the next couple, and we'll see how we did. Number 10 was a horizontal compression by 1/2. It was also a shifted down 3 units. Number 11 was a vertical compression by 1/2 and went left 2. Number 12 was reflected about the x-axis and horizontally compressed by 1/2. Okay, again we'll switch things up just a little bit. I'm going to first identify whether it's been compressed or not, and I see that here. We go up 1 and then over 2 at 1, 2, 3, 4. So nope, that's where it would normally be, so it has not been compressed at all. It hasn't been reflected about the x-axis, so that means all it's done is been shifted. So y equals, oh, then we'll see the parent function, is f of x, is x squared. So y equals x, and because it's shifted right 2, x minus 2, and then down 2 means minus 2. Alright, so try the next couple of problems, and we'll go over them together. Pause the video now. All of these, by the way, have the parent function of x squared, so I'm not too worried about that. G of x, so negative x means it's been reflected about the x-axis, and then minus 1 because it's been down 1. Number 15, it's been compressed vertically by 1/2 and reflected about the x-axis. You could have also used this and still been correct. So if you would have said that it was stretched horizontally never mind, I'm not going to try again that. Yeah, I'll go with that one. Number 16. Okay, so here's the one where I get an alternate. Instead of using that, you could have used 1 over 9 x squared minus 1. So instead of a horizontal stretch by 3, you could have done a vertical compression by 1/9, by 9. 1/9. So either one of those would have worked. Okay, here we go. Now we get into what's slightly different. So for solving quadratics, we're going to factor these first. We've done some factoring already. We're going to set stuff equal to 0. Okay, that won't really be new. So let's say I factor and I get this. Well, I'd set each part equal to 0. So solve each one and get x equals 2, x equals negative 3. I'd get that. And so I'd say my answers, that's my answers, but I notice that this one and this one are the same. So instead of circling all 3 of those, I would say my answers are x equals negative 3, comma, 2, because I got x equals 3, and I got x equals 2, but with 2, because it occurred twice, I would put MULT period 2, and that just stands for multiplicity. And multiplicity just tells me how many times it's repeated. So that value was repeated twice. So I put multiplicity, or MULT period, of 2. Now, why that's important is multiplicity of 2 affects what the graph looks like. Normally, we're used to seeing things that look like this. Okay. Well, when I solve a quadratic and I set it equal to 0, I'm figuring out where it touches the x-axis. So in that case right there. If it just goes straight through the x-axis, that means I had a multiplicity of 1. I got an answer occurred 1 time. If I get something like this though, let's say it touches the x-axis. It looks like that, or it's flipped the other way, but basically it touches the x-axis and then goes back the direction it came. That meant that at that value right there, it occurred twice, or it has a multiplicity of 2. And then my third case is, well, what if it has a multiplicity 3. What if I get the same value if I solve an equation, and it won't be a quadratic because quadratics have at most 2, but for future reference, let's say if I solve one and it occurs 3 times, well that means it will come down, touch the x-axis, and look kind of like number 2, but it'll go back down. So it comes up, flattens out, and then continues on. So those are my 3 cases of multiplicity, and that's why we're actually going to be specific and say what kind of multiplicity we have. If we have multiplicity of a repeated 0. So for each one of these, we're just going to say equals 0 and factor. For this one I have 2 terms, so I'm just going to factor out what they have in common. Set each part equals 0. And then solve. Well, that one's already solved, so I have this one as x equals negative 3. Neither one of those is repeated, so those are my answers. I end up with 0 and negative 3. Go ahead and try these next couple, and because this might look a little different, I am going to actually work through these problems. So go ahead and pause the video, but if you get stuck on any, just play the video and I'll actually work through these problems. Alright, number 18, set equals 0. I really would like to factor out a negative 2, but I cannot factor a negative 2 out of both terms, so I'm just going to factor out the x, leaving me with negative 2x plus 7. So I get x equals 0, negative 2x plus 7 equals 0. Subtract 7 from both sides. Divide by negative 2. And I get x equals negative 7 over 2. So those are my 2 values for x. Neither one of those was repeated. This one right here, not working because it was very similar to the first one. You get x equals 0 and x equals 4. This one has 3 terms in it. Well, I would like to be able to factor out a negative 2, but unfortunately that negative 11 is posing a problem. I can, however, factor out a negative. Yeah, that. And so we're trying to figure out what multiplies to make 2x squared. We'll put that here and here. What multiplies to make 12? Put that here and here. Except that when we FOIL that out, we have to combine to make 11x. So to help us visualize this, we're going to draw our little Punnett square box. And I take the first term, put it in the first box. The last term, put it in the last box. And think, okay, well, what multiplies to make 2x squared? Well, 2 times 1 is the only thing that multiplies to make 2. X times x, the only thing that multiplies to make x squared. Well, what multiplies to make 12? Well, 3 and 4, 2 and 6, and of course 1 and 12. The only catch is that if I try to make one of those add to make 11, I cannot, but that's okay because my catch is that one of those is going to be multiplied by 2. Whichever number is right here is going to be multiplied by 2. So let's think about this. If I multiply 3 by 2, well, if I multiply this one by 2, I'd get 6. 6 plus 4 is 10. That doesn't work. Well, what if I multiply the 4 by 2? 4 by 2 is 8. And then plus 3, 9, 10, 8, 9, 10, 11. So I'm going to put the 4 here, the 3 there. Well, 4 times 2x is 8x. 3 times 1x is 3x. And these two boxes should combine to make that term in for my box. They do. So I'm going to say, okay, this goes here. That here. And then I factored it, so I'm going to set each part equal to 0. And I can ignore that negative out front. So this will say 2x plus 3 equals 0. And then 1x plus 4 equals 0. And I get x equals negative 3 over 2. This equals negative 4 as my answers. Okay. So for 21, this is one where we actually get a multiplicity. So x times x multiplies to make x squared, and 2 times 2 multiplies to make 4, and adds to make positive 4 in the middle. So this one was simple enough, I didn't really need my box. Set each part equals 0. And get x equals negative 2. Well, now we finally got one that actually repeated. So my answer is going to be x equals negative 2 multiplicity of 2.
Staff, the testing committee is meeting in the guidance conference room at this time. The testing committee, you'll be meeting in the guidance conference room at this time. Thank you.
For number 22, you should get 0, because x, the reason why is I know that x squared is the same thing as x times x. So x equals 0, x equals 0, they equal the same thing. And that was the last one. So I will, the sub should have your homework paper, and I will see y'all on Wednesday.